Okay, so we're back. This time we're going to go over what's called the unit circle arrow and beyond. Because before we kind of limited ourselves to a circle with the radius of 1. Okay, so any triangle that you made, the hypotenuse was always 1, as you can see right here. Okay, the hypotenuse is always going to be 1 because the radius is 1. So we're stuck with that as the only triangles we can have. But what happens if we have a hypotenuse on a right triangle that's not 1? That's any other number that we want. What should we do? Okay, that's what this whole video is going to be about right now. So say we have another triangle that's a similar triangle to this triangle right here, and I just drew it right here. Okay? Similar triangles, if you remember, it's the same exact measurements of all the angles. All the angles are exactly the same on the triangles. The only difference is it's a multiple. So say this one has a hypotenuse of 1. This one could have a hypotenuse of 2 if you want. Okay? They're still considered similar because they have the same angle measurements. Everything's the same. It's just that the lengths are different by a certain multiple. In this case, by 2. So this wouldn't be y anymore. This would be 2y, and that wouldn't be x anymore. This would be 2x. You see how they all are multiplied by 2? Okay? I just used the number 2. You can use 3, 4, 5, any number you want, as long as because any number is technically a multiple of 1 anyway. Okay? So that's how that works with similar triangles. Quick review. You guys probably remember that from geometry, though. Okay? Now, how does that relate to our trig functions? Well, the trig functions we had before were fine for the unit circle triangles. But for any other, and beyond, for any other triangle, we have to kind of change these equations a bit. Okay? So, if the hypotenuse isn't 1 anymore, these end up being a multiple of what they were before. So that means we actually have to add an extra number. We have to multiply this trig function, this sine, by a certain number. And that number is the number that's right here. Instead of 1 for the hypotenuse, say it was 2, 3, 4, 5, any number, that's what you'd have to multiply the sine function by. So this function would end up turning into y is equal to the hypotenuse, so whatever the length of this is, I just put h, whatever the hypotenuse is, actually, even better, I'll do it by the radius. Whatever the radius is for that circle, so I'll just put r times sine theta. Okay? This would be for any circle that, well, technically this would work for any circle, because for a unit circle the radius is 1. So you'd end up getting the same thing here. 1 times sine theta is equal to this. So this would actually be a better equation to use to find sine, to find the y, using the sine theta. This cosine, the exact same thing as it's a multiple. It would just be the radius times cosine theta. Now with tangent, you don't actually need to do anything. If you wanted to, you could add the r's in here, but it doesn't matter because they would just cancel anyway because you're dividing. So r over r would just cancel. So you end up with the same exact function regardless for tangent. So that doesn't matter so much with tangent, but for sine and cosine, it's really important to know that you actually have to multiply by whatever that hypotenuse is. Okay? Then we end up with these two functions. R times the sine theta and r times cosine theta. We're going to talk about this more when we look at other right triangle trigonometry, but I hope that helps figuring out the unit circle and beyond. Okay? Let me know if you have any questions.